For any triangle ABC, prove the following. Let us begin. First, we'll try to understand few terminologies that are being used in the problem. Let us consider a triangle with vertices A, B and C. Then, the sides opposite to angle A, angle B and angle C are represented by A, B and C in lowercase respectively. If we take the sum of the three sides A, B and C, that's going to give us the perimeter of the triangle. We're going to take the half of that perimeter, and this is going to give us S, which is referred to as the semi-perimeter of the triangle ABC. Okay, we'll start our problem from the left hand side. So here, the first term is given by 1 over A multiplied to cosine squared A over 2. However, we're going to rewrite cosine squared A over 2 as cosine of A over 2 square whole square. This will become evident in a moment. Next term is 1 over B multiplied to cosine of B over 2 whole square, added to the third term, which is 1 over C multiplied to cosine of C over 2 whole square. Fine. This is going to be equals to, now what we'll do, we'll use the value of cosine of A over 2, cosine of B over 2 and cosine of C over 2. There is a standard formula for it. So let's note it down. Now cosine of A over 2, now this is given by, so what we'll do, we'll take the square root. Underneath the square root, we will take the perimeter, semi-perimeter S, multiply it with S minus the side that is opposite to angle A, which is going to be A in lowercase, divided by the product of the two adjacent sides of angle A. Now for angle A, the two adjacent sides are C and B, so we'll take its product, C times B. This is going to be the formula for cosine of A over 2. Similarly, we can define cosine of B over 2. The cosine of B over 2, that's given by the square root of S multiplied to S minus B whole divided by AC. And then cosine of C over 2, that's defined by the square root of S times S minus C whole divided by AB. So now we have defined cosine A over 2, cosine B over 2 as well as cosine of C over 2, and we're going to substitute this value into the respective position. So that means the left side is now going to become 1 over A. That's going to get multiplied with the square of cosine of A over 2. That means we have S multiplied to S minus A divided by BC, added to cosine 1 over B multiplied to cosine of B, so that's S times S minus B divided by AC, added to 1 over C multiplied to cosine squared C over 2, so that's S multiplied to S minus C divided by AB. Now what we can do, we can factor out S over ABC from each of the three terms, which is going to leave us with S minus A plus S minus B plus S minus C. Now we are going to further simplify. This is going to be equals to S over ABC multiplied to, so S plus S plus S, that's will be 3S minus we have A minus B minus C. Now what is A? If we take negative as the common factor, then what we can do, we can rewrite it as S over ABC multiplied to 3S minus A plus B plus C. Now what is A plus B plus C? So in terms of the semi-perimeter of the triangle, A plus B plus C is simply going to be 2 times the semi-perimeter. So we'll use this value. So we have S over ABC multiplied to 3S minus 2S. Now that's going to leave us with S squared in the numerator. So we have S squared divided by ABC, which is going to be the expression on the right hand side. So hence we have successfully verified that the left hand side equals to the right hand side. So let's look at the problem once. Yeah, so here we have on the right hand side S squared over ABC, hence proved.